Hi guys, welcome to Learn Electronics Repair, and I have a multimeter oscilloscope to review today. This is from FNIRSI. I've looked at quite a few of their products with very few exceptions. They tend to be very good, to be quite honest, especially for the price point. So let me just show you what this is, how much it costs, and then let's take a look at it. The DST-210 is available in these sort of prices. Now note there are actually two versions of this, the 201 and the 210, about 10-11 euros difference in price. So if you want a particular version, just do check what you are buying. And also this month you may find coupon codes which are available for you to use on almost anything on AliExpress. So video description, guys. Now let's have a look at this multimeter oscilloscope. As I mentioned, two versions of this, or rather two very similar models. As far as I'm aware, the multimeter is the same on both models, okay, the 210 and the 201, the difference being in the bandwidth of the oscilloscope, okay, and the sampling rate. So you can see there 10 megahertz or 1 megahertz, okay. Again, some other differences. So you'll see that there are two different versions of this, as I say. Make sure you know what you're buying. We have a signal generator as well. So this is one of these 3-in-1 products. Let's take a look at the meter itself. And first impressions. It's quite chunky. Not very heavy particularly. It's certainly something you'll know you've got in your hand. Just take the screen protector off there. This has a stand. Okay. Let me see. Yeah, that's fairly solid. Okay. This is something I would use on the bench or on the desk. It's not something I'd probably hold to use particularly, but I only have quite small hands actually. So we have the oscilloscope inputs and we have the multimeter inputs, okay? What else is in the package? Well, we have an instruction manual which is multi-language, or rather Chinese and English, okay? I generally like to see if I can work these things intuitively. Some people say, Richard, go and read the manual, you make yourself look stupid. Well, it's a multimeter and oscilloscope, so I would like it to have an intuitive user interface. If I need to refer to the manual, of course I will do. This may also mean that I miss on a few of the features this has, but let's see what happens if we just try to pick it up and use it, okay? Firstly, power on. Well, there's a power on button on the side. Yeah, it's booting up. We have some menu options. You see, intuitive, English, enter. And then the modes, multimeter, oscilloscope, signal generator, and settings, okay? Let's have a look in settings. So we'll just press OK on this. The screen is nice and bright. I mean, guys, you know I have some very bright overhead lighting on my bench, but this is easily readable really, so sound and light, that's on maximum brightness. I'll turn up the bleeper because it'll help you guys hear it when I'm actually testing the multimeter. Let's see, so press enter and then maybe, let's see, down, yeah. That's the brightness, up. That's the volume, okay. It's not particularly loud, this one, by the way. You may consider that to be an advantage or a disadvantage. We have start up on boot. So you can, effectively, if you choose none, that will go to that menu we saw when we first powered this on. Otherwise, you can get this automatically to go into one of the options. Probably the one you're using the most, I would suggest. Theme, so this will alter the screen colors, I would say, so night or day. So let's see, we press enter and we can go to day. How does it look? Okay, I think so far I prefer that one. I've noticed from what I can see, you press the power button one short press to save the settings that you've set on this. Okay. Auto shutdown, so you can have that off, so this will just stay powered on, or you can set it to shut down automatically after a period of time, and quite a lengthy period, which is probably quite handy actually. I think for most uses for me, 15 minutes is probably a good option. And USB sharing, so I did check in the manual, this doesn't display what you see on the screen on your computer or such like. This has an option to actually take screenshots with the run save button, and you can then share those files with your computer. In fact, it says USB sharing. After turning on, you will enter the USB sharing interface connecting your computer, and you see a flash drive, okay, and you can get screenshot images in the screenshot folder, and you can also place or replace this file, so you can have a custom startup logo. Okay, so I think that's enough for the settings. Let's try the meter itself. The mode button switches between the multimeter, the scope, and the signal generator. Okay, that's how that works. And then we have various options on here, so I can see volts, ohms, continuity, I would say that one is, diode test, capacitance test, frequency, temperature, and the temperature is correct, by the way, for my workshop from what I can see. Current, and it's telling me to use the correct positions. Amps, okay, milliamps. What else do we have in the package? Let's see. Well, the usual little quality tag thing. Okay. We have an oscilloscope probe, fairly standard one. Okay. A USB-C charging cable and for connecting to your computer. Yeah, this type of clip-on to BNC cable. And 2 meter probes. Let's look at these meter probes. Oh, these are nice sharp ones. This is a personal preference, guys, but I like these needle type probes with long ends on there. You can get down inside connectors and such like. I know you guys have your other choices, and you also know that I tend to use my own probes anyway rather than the supplied ones, but these I could use. They suit me, okay? I wouldn't be surprised if you could cut the end off this and have just a bit sticking out at the end, although I haven't tried that, of course. If you've watched my videos before, and you probably have, if not, welcome. Okay, so with the multimeters, I tend to test certain things. I do this the same on all the reviews that I make. So I look at the resistance range on very low value resistors, 0.22 ohm, that sort of value. That's probably the lowest value I'm likely to come across during repair work, and I'm mostly a repair guy, so I'm going to review this basically within those parameters. Okay, voltage, I usually just accept this thing will measure volts. I can stick it onto my bench power supply and just vary the voltage a bit. I don't think there's much to say about the voltage really. I also like to just check some fairly run-of-the-mill resistors, maybe 10k or 100k, and then very high value resistors such as 10 meg, because if you're going to have a problem with the ohms range, it's probably going to be with very low or very high value resistors. That's my experience. I don't have any reference resistors, very close tolerance here. I can compare this with my other multimeters like the Fluke, but to be honest, that isn't calibrated either. So I would treat this as a kind of a hobbyist piece of equipment anyway, not a high or super high precision meter. So that's how I'm going to test the resistance. Continuity and diode test. What I want this to do is pass the Mr. Bleep test. So in this case, continuity, I want it to give me continuous bleep, and diode test, I want to give me a continuous bleep if it's a short, and a short blip if it's a diode or semiconductor junction. Capacitance test, I'll just do some very low value around the 1 picofarad or thereabouts, see if it will read them. Something typical like say 100 nanofarads, and then very high value electrolytics to see how long it takes to read them. Normally with the multimeter, when you're measuring very large capacitors, it takes a long time. Frequency, temperature I don't tend to bother with. 10 amps, yes, I'm going to stick it onto my bench power supply, stick some amps through it, just make sure it's happy with that. And then milliamps, I want to see if this will read down into the microamps range, because this is something I often do with motherboards where I want to, for example, see how much current draw is from the CMOS battery. That tells me a great deal about the state of the chipset on the motherboard, and I'm expecting to find anywhere from about 1.5 to 10 microamps, okay? Some multimeters will read that, some won't. So that's how we're going to test this multimeter. Let's give it a go. Very low value resistors. Now, most multimeters cannot easily do this. You need to have a multimeter with a Kelvin probe, that's a 4 lead probe, to measure these, a micro ohm or milliohm meter. But some do better than others. So this is a 0.22 ohm resistor, but it's a dual one. So across the ends is 0.44, and from either end to the middle is 0.22. Let's see what it does. So we'll go with the 0.44. It says it's 1 ohm. Let's just check what the... Yeah, so it's reading about 0.4 on the leads. I don't see any obvious method to zero this, but then you often don't with a multimeter. So if that reads 0.4, this should really be about 0.8. Yes, I know I have my fingers across it, but on low resistances that won't make any difference. So it's giving about 1, so about 0.6. And to here, about the same. So this one will not read very low value resistors. A lot of multimeters won't, in actual fact. If that's something you specifically want, look for a milliohm meter. Some do a bit better than others, I will say, obviously. 100k, and this time I won't put my fingers across it. Yeah, I mean, it's very close, and these are not particularly absolutely close tolerance resistors anyway, so that's fine. And 10 meg resistors. My Fluke, for example, reads these is about 11.5 meg. Again, I don't really know the tolerance of the resistors. That is actually better than most, to be quite honest. Okay, that worked very well, I would say. Continuity. I'm particularly interested in how fast these are. That's very responsive on the bleep. This is quite common. Almost all multimeters will bleep before they display. I have seen at least one that was the other way around. So it takes a little while to actually show a reading, but I hope you guys can hear it. Very fast on the bleep. The Mr. Bleep test. Now, very few multimeters will do this. So that reads short, but it doesn't bleep. I'd like to have a long continuous bleep there. This, I would like to get one blip. I don't get any sound. Okay, it reads the diode, and this is a Schottky diode. This was a 1N4007 silicon rectifier diode. The Schottky should read quite a bit lower, 0.17. Okay, so it's reading them. What does it do with diodes in the continuity? Will they blip? No, it neither reads them nor do they blip. Okay, so that's how that's working. Because I always test the meters this way, you can go to my other reviews and you can compare one another easily. I think that's a good reason to do this kind of standard method of testing. Hope you agree. This is a 1 picofarad ceramic disc capacitor. These things are not particularly close tolerance. I've had other meters that do read this at about 1. This will not read it at all. Okay. No. I've had some that will read them. Okay, so this is a 12 picofarad. Normally when you get around 10 picofarads or so, the multimeters will read them. Let's see. This one, no. These are 100 picofarads, not 101 by the way. That's 1 0 and 1 more 0. And now it reads it. So somewhere above 10 picofarads it will read them. Whether this is important to you will depend on what you are doing. If you're into RF circuits and such like, you will want to read very low value capacitors, otherwise probably not, okay? This is a ceramic disc. You can see 104 on it. This is 100 nanofarads, but these probably read about 50 or 60 when I've tested them before with various other meters. 105 actually, so it reads that very well. So in this sort of range, it's absolutely fine. And now large ones. So this is a 3300 microfarad. Most multimeters will read these, but they're slow in doing so. Let's try this one. That one is fairly slow. I've seen quicker. But it does read them. Again, remember the tolerance on those sort of capacitors is maybe 20%, so you don't expect them to be very accurate. That's not anything to do with this multimeter, it's the capacitors. Okay, so current. I've put the leads into the position for the 10 amp range. I'm on the 10 amp range. This is my bench power supply. I hope you can see that clearly enough. So 0 volts, 0 amps at the moment. I have the current limit set down, so even if I turn the voltage up, it won't give any reading. So I need to give it some current now. So let's just yeah, 1.64, 1.67, 1.67. Yes, that's very close to what it's actually reading. Just give it a lower amount of current. 370 milliamps. Bear in mind this is only 2 digits, okay, so this could easily be 381. Now let's just turn the current up. So we're up to 10 amps. That's reading 10 amps. Most multimeters will give you a certain amount of time before they overheat or the fuse blows or there's a thermal trip, but that was certainly reading 10 amps. And while we're here, let's just go to voltage. So volts. And I will say, by the way, I much prefer this type of adjustment on a multimeter than the things you have to press various buttons to step between ranges. I mean, this is just such an intuitive thing to use. I honestly don't know why anybody thought anything was ever better than that. Discuss. Yeah, so kudos for that. So I'm now on the voltage range. Let's just increase the voltage a little bit then. 26 volts, 2632. Yeah, very close. Let's just get down to some low voltage. Okay. You can see this is taking a long time to drop because there's no load on the power supply, basically, yeah. Nothing to load it, nothing to discharge the capacitors. That's the power supply, by the way, nothing to do with the multimeter. Yeah. Let's just set some voltage then. 0.5 of a volt, 0.56, okay. Yeah, so voltage also working fine. Let's try the milliamps range. So milliamps, again, it's telling me how to connect this. Milliamps. This should go down to 1 microamp. Okay, let's see if it will. So to do this, I'm just going to connect onto the lithium battery on this motherboard, the CMOS battery, and I'm going to push the clip back so effectively I'm in the circuit. And I'm expecting it to draw a couple of milliamps or something. And that doesn't show anything. I'll show you what I'm expecting here. And I will say again, not all my multimeters will do this. I normally use this one or the little anemometer specifically because they will. My Fluke won't, I'll tell you that. So again, on here, push it back. There you see, it's almost 2 microamps, so it should read that. And the CMOS battery current is something I measure regularly in real life repair work, so that's not exactly a scenario specifically for multimeters not to be able to do it, okay? I'll conclude the test of the multimeter at this point. If you want to see any more features of the multimeter, we have a live stream every second Sunday. Mention in the comments, we will do it on the live stream. If you can't make it to the live stream itself, doesn't matter, because you can see afterwards, you can watch the live stream. So anything you want to see regarding this multimeter, just let me know and I will do that. So now I'm going to move to the oscilloscope feature. And this is quite simple, so just press the mode button. I'm now on the scope. Like I did with the multimeter, I'm going to test the oscilloscope in the way I've tested most others. So the first thing, I'm going to take my RF signal generator, the one I built, DIY, and let's see if this works at the stated bandwidth of 10 megahertz. But in actual fact, often I find these scopes will show me the sine wave from this and display the frequency at higher than the rated spec. So let's see what this one does. And here we have it. So I have my SIG-Gen at 7.195 megahertz. That's the default it boots up. This is set to amateur radio bands. I really need to load the other firmware on that Tim's project's made. But it's loaded on, and while we were just chatting, it's figured it out. I didn't even hit the auto button in actual fact. And what do we see? Well, it says it's 5.2 kilohertz. Okay, so I'm going to hit the auto. Now what does it think about it? Now it's got it. Okay, so I hit the auto. Very clearly, the sine wave out of this generator isn't particularly brilliant, and it's giving me 7.2, 7.3. So 7.195 is what this is set to. Again, I can't say this is exactly calibrated. That's reasonably close. Depending on what you want to do, whether the frequency is absolutely important to you or whether you just want to see is the thing oscillating, yeah? So that's what we have on the scope. Now I'm just going to go up onto the next band, which I think is 10 megahertz on this one. Yeah, 10. So there's, say, 9.9, 10. It's hit 10 at that point. It may actually vary depending on where I set the trigger point on this. I'll also try hitting auto again as well. That's another thing we can just do. So okay, it's got it, 10 megahertz. Yeah, that's pretty accurate. Can we go up much more than this? Let's have a look. Well, let's go up to another band. So that's 11.78 auto. That's confusing. Now, obviously, I am above the specified rating for the scope, okay? So we do at least have a signal. It's struggling somewhat to read the actual frequency. But I'm running this above its spec, okay? Let's go again. What do we have? 13.6. Again, so it's actually showing me with, again, some loss of accuracy here, okay? 14.1. Yeah, it's actually got that. Again, with a little bit of jitter in it, so not perfectly, but at least we can see there's a signal. Would this, for example, tell me if I have a 25 megahertz clock on the crystal? Let's see. And this is way above. Well, that's 27 megahertz. And it tells me I have it. I mean, it's struggling. But you would probably be able to see if, for example, a motherboard crystal is running or not. Okay, so that's how it performs. But at 10 megahertz, yeah, it was working. So I'll have to say it did work at that. It's specified maximum frequency, okay? The other method I use for testing oscilloscopes is some real life scenarios. So one of them is real-time clock crystal on the motherboard. I do have the scope connected grounded to the motherboard, by the way. I often do it this way. So this is actually plugged into the signal generator output, but I'm not using a sig gen. I'm just using that as a ground lead connected to there. I could use the one on this, but I find them too short basically. So other option, I'll just extend that with a crocodile clip lead. But this is the way I do this normally, so I'm doing nothing different to what you would normally see me do. So real-time clock crystal, let's just try it. Yeah, it's running 32 kilohertz, okay, so that's fine. The other one I would normally check is the 25 megahertz clock. Now we know that this scope is not specified to run at this frequency, but we can have a look. And on this motherboard that is here, it's easiest to measure on the capacitors which are near to the crystal. Will this tell me if the crystal is actually running? Not on the auto range. I just go to the other end of the capacitor in case that's actually the ground end I'm on now. So that's here. Yeah, again, it can't detect it, but guys, that's a 25 megahertz clock. It's a very low level signal. This scope is not specified to do that anyway. Another real life scenario would be looking at the VRM, V-core VRM. So we can just have a look at the MOSFETs and see what we can see. Yeah, there is the VRM running 295 megahertz. I've measured this before, you can see on other videos. That's fine. So yeah, that works well. And the other tests I would normally do real life are going to be on the switch mode power supply. And here is the switch mode power supply I use for testing. So this one has a 12 volt output. It can supply a couple of amps. When there is no load on, like at the moment there's no load attached to it, it goes into burst mode. So effectively it's kind of cycling along, so it's not continually driving the output, but it does it in bursts. So you get a few, like a drive pulse or so every so often. You're just maintaining the voltage. Because the waveform is quite transient in this respect, this can be quite difficult for a scope to trigger on, so I think it's a good test. And then we'll actually attach a load and we'll show where the power supply is running. So the first thing is, can it actually trigger and show us that this is in this burst mode? I have the probe set to times 10 now. I have this set to times 10. I had it on times 1 previously. The scope probe was on 10 and it was displaying the frequencies pretty well. It made work a little bit better. I should have set this correctly, but if you want to see that, I'll happily do it on the live stream. Okay, for now let's just try this. So we power up, it's gone off the screen, press auto, let's see what happens. And we see just the high voltage there. Okay, try and trigger this again. And something is there. We go again. And you can see it. Can you see every so often like a little there? Yeah. So that is the occasional pulses which are just keeping this running with no load. That's kind of like I expected it to be. We could go to AC and see that bit bigger. It's better that time. So it is showing us that the power supply is running. If I switch this off, you'll see the voltage drops away. Yeah, it's trying to run more often now because it's trying to maintain the output voltage. Okay. So it picked up the transient pretty well. It took a couple of presses, but then it got it. As I say, this is quite difficult for scopes to trigger on. Yeah, you see it there. So let's attach a load to this and then see what we get. These are 10 ohm each, so that's 20 ohms. This is 12 volts out. So, well, if it was 10 volts out, that's half an amp. It's a bit more. Let's say 600 milliamps. So 12 times 0.6 is about 7-ish. Yeah. So this probably dissipates about 7 watts. I'm quite happy with that. Let's see what the scope makes of it. So we're going to power the thing up again and hit auto. And now you can see the power supply is running. Yeah, it's running continuously. There you go. It has it. And it has it quite well. The reason it's flickering, this is like still in a kind of like a burst mode, so it's not running all of the time every cycle. It's just doing that to maintain the voltage. We've seen this actually before. So again, yeah, that's fine. That's quite happy. It's on 100 volts per division, and then we can see we have sort of 400 volts of signal there. In fact, it's telling us 404 volts. Okay, at 91 kilohertz. So once again, we power it down and it will, okay, that. So yeah, it passed that test. That's the great thing with these sort of scopes. It's ideal for measuring things like this, which are not isolated from the mains. I will mention, by the way, that this metalwork here, this will be at hot ground. If you touch that, you will get a zap from it, okay? Could be quite a nasty one. So I would prefer to see this more enclosed so you can't easily touch it. But this is one of these cases, if you understand what not to do, then you should be fine. All this is plastic, okay? I don't see any screws that you could touch easily, so I'm happy enough with that. The last thing then, let's just have a quick look at the function generator. Okay, so I have the signal generator set to 10 kilohertz square wave. I can actually take this up to, I think it's 50 kilohertz, the highest. Okay, so that's at 50 kilohertz. This is clearly showing 50 kilohertz, so that's just fine. And then we can change the waveform on here. So for example, I'm on 1 kilohertz, that's the triangle wave. Yeah, fine. Half wave, full wave, step wave, a reverse step wave. Yeah, we have a variety of different waveforms here. Index up, that's called. Index down. And then we have a direct control. So we have other options we can actually set on here as well. Okay. Let's just go to a sine wave because we didn't try sine wave. Yeah, and there's a sine wave. So the function generator seems reasonably well featured, to be quite honest. We have quite a lot of options on there. I usually find this is the function that works well on just about all of these all-in-one piece of test equipment, and yet it's the one I probably least use, but that's just probably down to my usage, being a repair guy more than a hobbyist guy. Okay, how to sum this one up? Well, it has quite a lot of functions, all of which basically work. One thing I did notice I didn't mention, by the way, is if you want to get to multimeter mode, just turn the dial and you're directly in. Yeah, and then press mode to get back to the other. So that's a quick way of doing that. I quite like that. In fact, the whole thing with the dial I like, because this type of operation is much easier to use for me than anything else when it comes to a multimeter. The scope, you really need to look at the manual, because I wouldn't say it's totally intuitive, but learn to use it, and okay, I think it's not a bad scope, to be quite honest. The multimeter, I would like to see more accuracy, especially on low value resistors. A few other things, this thing with the continuity and the bleep test on diodes. But again, that's something fairly specific to me. with repair work. And the reason I want that, by the way, is when I'm probing on a motherboard, I don't want to look at the meter. I want to hear continuous bleep when I'm on a short or very low resistance, and a blip when I'm on a diode junction or transistor junction. Okay, so all in all, I'll leave it to you guys, this one. I've shown you the main features of it. You can see what it does. Yeah, for a hobbyist bit of kit, I mean, back in the day I would have loved this, you know. There's a lot of these things around now, but back in the day, I mean, I would have absolutely loved this thing. If you're into RF stuff, obviously you'll probably want a higher frequency than this scope can handle, but not all of us are doing that sort of work. It triggered on that switch mode power supply just fine, even when it was in burst mode, and I had some that really struggled with that, so that it did. So in this one, the summing up is, you make your mind up, okay? And let us know down there what you think of it, okay? So thanks for watching. I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.